Okay, in this lesson, we're going to be talking about probably the most important topic in all of trigonometry, and that is the unit circle. And we're going to start out our discussion on unit circles by talking about reference angles. So let's define what a reference angle is. For any angle, we're going to call it theta in standard form. This could be in any quadrant. The reference angle is the positive acute. So it has to be a positive number and it has to be less than 90, or it's not a reference angle, formed by the terminal side and the x-axis. So you're going to take your terminal side and you're going to take the nearest portion of the x-axis. And that angle formed between that terminal side and the x-axis is your reference angle, no matter what quadrant you're in. So in each of these examples here, we're going to sketch the angle and then we're going to find the reference angle. We're simply telling pretty much how far is that angle from the x-axis. So just a reminder that here is your 90 degree. You're going to start here on your terminal side, which is 0 degrees. Here's your 180, here's 270, and then all the way back around would be back around to 360 degrees. So 150 is going to be located somewhere right in here. It's nearly 180. So the reference angle is once again simply how far is that from the x-axis. How far is 150 from 180? And that would be 30 degrees. That's all you do. Number two, again, 315 degrees is somewhere between 270, which is here, and 360, which is here. So you've got your 0 degrees is where you start. 315 is going to be somewhere right in here. You're going 90, 180, 270, and then 45 more. However, your reference angle is how far is that to here? And again, we know that back to there would be 360. So you're simply saying how far is 315 from 360? Subtract the two and you get it's 45 degrees away. Now, negative 240, a little bit trickier. Let's start at 0 degrees. We're going to rotate in the opposite direction. We're going to rotate 90, 180, and then a little bit further. So negative 240 is going to be somewhere right around in here. So we went 180 degrees from here to here, and then we went an extra. You've simply got to say how far extra did you go past 180, so you could actually just worry about the 240, take 180 from that, and this is going to be 60 degrees from the x-axis. So the distance from here to here would be a 60-degree angle. And by the way, remember that it has to be a positive acute angle. Radian measures always change to degrees. Pi over 3, that's 180 divided by 3, which is 60. 5 times 60, this is a 300-degree angle. So here is my initial side. I'm going to rotate 300 degrees. That's going to be 90, 180, 270, plus 30 more. So 270 and 30, that gives me my 300. Again, however, to find our reference angle, we're looking for this angle. So therefore, if 360 is all the way around, so if this is 300, then this must be the other 60 degrees, which will be your reference angle. Next one, again, let's go ahead and change it. Pi over 6, that's 30. That's 180 divided by 6, which is 30. So this is 7 times 30. This is a 210-degree angle. So let's graph that. Start at 0 degrees. We're going to go 0, 90, 180, but we're graphing 210, so we're going to go a little bit past 180. And again, the reference angle would be pretty much how far past did you go. So you can take your 180 away from the 210, which is the total, and that's going to leave you with 30 degrees. That's how far past the x-axis you went. So 30 degrees is your reference angle. And then finally, negative 5 pi over 4. Again, we're worried about the pi over 4 first. Just leave the negative symbol. 180 divided by 4 is 45. 45 times 5 is 225 degrees. So we're going negative 225. So start with your initial side. We're going to go negative 90, negative 180, and then a little bit further, we're in the second quadrant here. And again, the question is, how far are we from the x-axis? The nearest portion of the x-axis. Well, if this is 180 from here to here, how much further did we go to get that entire 225? You can simply do 225 minus the 180, and that leaves you with a 45-degree reference angle. Okay, for this next part, it says use reference angles and the trigonometric function values for angles in special right triangles to find each trigonometric value. So this goes back, reminder that we did that chart, the sine of 30 is a half, sine of 45 is root 2 over 2 in our notes a few lessons back. So we're going to use that along with our all students take calculus, to where we know that everything's positive, sine's positive, tangent's positive, cosine's positive. So it says recall the signs of the functions in each quadrant, which goes back to that. Now, how are we going to connect those two? Okay, our reference angles. If I know, let's zoom in on what I've drawn here. Here's 120 degrees. We're asked to find the sine of 120 degrees. The way that we're going to do that, if this is 120 degrees, I know that my reference angle is a 60-degree angle. So if I'm in the second quadrant, first off, let's deal with all students take calculus. I know that in the second quadrant, sine is positive. So I know that my answer is going to be a positive value. Along with that, in order to find the sine, we'll look at this triangle I have now. If I use my reference angle, which is a 60-degree angle, I can actually just find the sine of 60 because that's the triangle that I've got drawn using my reference angle. So instead of sine of 120, I can actually just do the sine of 60 instead. And the sine of 60, looking back at our chart, is going to be root 3 over 2. So the sine of 120 is going to be positive root 3 over 2. Let's do another one. Secant of 225. And again, I'm not comfortable with secant of 225. Let's find the cosine of 225. And then once I find my answer, I know that I can just flip it. So let's take and sketch 225 degrees. I know that 225, let's see, this is 90, 180, 270. So 225 is going to be somewhere right in here. And I'm going to draw myself a little right triangle. My reference angle here, if this is 180, then my reference angle is 45 degrees. I went 45 degrees beyond that 180. Let me draw that a little bit better. Okay, there we go. So first off, we're in the third quadrant. All students take calculus. So the only thing positive here is tangent of the original 3, so therefore cosine will be negative. And also we can use this triangle right here to find out what the cosine is equal to. The cosine of this 45-degree angle is going to be the same thing as the cosine of this 225. Cosine of 45 is going to be root 2 over 2. So therefore the cosine of 225 will be a negative root 2 over 2 because it's the same triangle. And number 9, the tangent of 11 pi over 6. Again, I don't like working with 11 pi over 6. So we're going to change this to 30. 11 times 30 would be the tangent of 330. Let's draw ourselves a triangle, or excuse me, first off a quadrant. Here, 330 is going to be somewhere down in here. As long as you're in the right quadrant, it doesn't matter what your triangle looks like. So 330, first off our reference angle, if this is 330, how far is that from here would be a 30-degree angle. So we can actually, instead of 330, we can worry about a 30-degree angle. So let's use that reference angle to find the tangent of 330. Let's determine if it's positive or negative. All students take calculus. Cosine is the only thing positive, so therefore tangent is negative. The tangent of 30 degrees, again, you can look back at your chart, is going to be root 3 over 3. And number 10, cosecant of negative 2 pi over 3. Instead, let's find the sine, and let's go back just a second. Up here, we were actually supposed to find this secant of 225. Let's try that again. We found the cosine of 225, so the secant should have been the reciprocal of that, negative 2 over root 2. Once you rationalize that by multiplying top and bottom by root 2, that's going to give you negative root 2. So I forgot to flip-flop that, and this problem reminded me of that. So to find the cosecant, I'm first going to find the sine of negative. And again, let's change this to a degree measure. 180 divided by 3 is 60. 2 times 60 is negative 120. So let's do that. Let's draw a quadrant, XY axis here. Negative 120 is going to be, let's see, this is 0 here. Draw it in blue. This is 0. If you rotate negative 120, you're going to go, here's 90. So therefore a little bit beyond 90. So about right in there. Draw yourself a right triangle using the reference angle and ask yourself, how far are you now from this x-axis? If this were 120, so therefore you would be 60 degrees. Your reference angle is a 60-degree angle. So you don't have to worry about the 120 anymore. You could actually use a positive 60 because, again, it's the same triangle. A negative 120 and a positive 60 forms the same triangle. However, you do have to worry about all students take calculus. Tangent's positive, so therefore sine is going to be negative. Tangent is the only thing positive in that third quadrant. So now all we have to do is find the sine of 60. And the sine of 60 from your chart is going to be root 3 over 2. So the sine of negative 120 is negative root 3 over 2. And I nearly did it again. We're asked to find the cosecant, though. So we do have to flip that. That'd be negative 2 over root 3. If you flip it from the sine, rationalize that, gives you negative 2 root 3 over 3. Okay, let's define one other thing before we talk about the unit circle, and that is a quadrantal angle. And by definition, it says when the terminal side, or the ending side of an angle theta that is in standard position lies on the x or y axis. These are called quadrantal angles. So a 0-degree angle is a quadrantal angle because we're on the x-axis. A 90-degree angle is a quadrantal because it stops on the y-axis. A 180, a 270, and then if you rotate it all the way back around, a 360. All of these are quadrantal angles. And you see there 0 degrees or 0 pi, pi over 2, pi, and 3 pi over 2, which are those radian measures. Okay, now let's tie all that together and let's talk about what we mean by a unit circle. The unit circle. A unit circle is a circle with a radius of 1 unit. Because the value of r is 1 for each point xy on the circle, the trigonometric functions are defined as follows. So reminder of before, that before the sine was equal to y over r, cosine was equal to x over r, and tangent was equal to y over x. Remember all those? However, now that we've drawn this unit circle to where the r value is 1, look what we've got. Instead of sine being y over r, sine is equal to y. Cosine would be equal to x, and tangent would be equal to y over x. So therefore, cosecant, secant, and cotangent would be, again, just the reciprocals of those. And we can actually use this to the fact, okay, let's go back and remind you that any point, if you remember this drawing from before, any point, if you had this angle, this terminal side of this angle drawn, remember we said that we could use Pythagorean theorem, find any point on that, or to find the distance from here to that point. Well, look what we actually had here. We had the equation of a circle. X squared plus y squared equals r squared is the basic equation of a circle. And now that we know that the radius is 1, we now have this circle. X squared plus y squared equals 1, which is the equation of this unit circle that we're talking about. So now that we can look at this, okay, on this unit circle, look what we've got. This point, this sine and cosine values are related to a y value and an x value. So therefore, the coordinates of a point can be written as this. The x value is equal to the cosine of theta, and the y value is simply the sine of theta. So any point, if you're given a point here on this circle, the x value is the cosine, the y value is the sine. And that's so handy when you're finding these coordinates of these points on this unit circle, is that they're simply related to the cosine and sine values of that angle. So the next part, the 16-point unit circle, and you see a picture of it here. The unit circle is frequently used to map 30 degrees, 45 degrees, and 60 degrees, which are the angles that we went over, and all their multiples. Because if you were to do the multiples, then they're the ones that have the exact same reference. Like, look, this 150 degrees over here. Remember how we took and we drew that triangle that corresponded with it, and I told you, well, you can just use its reference angle there, because that would have a reference angle of 30 as one of the multiples of 30. So that's the reason we can use this. And also, as well as 0 degrees, 90 degrees, 180 degrees, and 270 degrees, which are the quadrantal angles. So you see all those angle measures here, 0, 30, 45, 60, 90. You see them all drawn, 120, 135, and so on and so forth, all those multiples, as well as, like it says, all the quadrantal angles, which are located here. So the next part says complete the unit circle reference, and we're going to do that in a separate video. And you can flip over that video now if you'd like. But I'm going to go ahead and we've got that completed. So I'm going to use the circle to find the exact values of each of the trig functions. So here's how we're going to do that. Again, we can simply say, okay, to find the sine of 135 now. We can use our unit circle if we'd like, but that's going to be a y value on our unit circle at 135. So we're going to sketch out 135. Well, before we do that, let's do all students take calculus, so that'd be cosine. 135 is located in the second quadrant, so therefore sine is going to be positive. We can now mark out 135, find its reference angle, which is 45, and simply find the sine of 45, which is root 2 over 2. Done. The secant of 180. Again, the secant value, we don't want to deal with secant. We want to do its reciprocal, which is the cosine of 180. And again, a cosine value is an x value. So think about where 180 would be located on that unit circle. It's located right here. So therefore, the cosine of 180, if we were to look at this point, that is the point negative 1, 0. So therefore, the cosine value is the x value, which is simply negative 1. However, the secant will be the reciprocal of that, which is actually also negative 1. The cotangent of negative 300, well, let's find the tangent of negative 300 first, and then let's flip it. So to find the tangent of negative 300, we can use, I don't really like negative 300. Here's another thing. We can use coterminal angles here. Add a rotation to that. So negative 300 is actually the exact same thing as the tangent of 60 degrees. And we know the tangent of 60, that's one of our common angles that we found. The tangent of 60 is going to be root 3. And since it's in the first quadrant, it's also positive. However, the cotangent of that will be the reciprocal, which is 1 over root 3. When you rationalize that, you get root 3 over 3. Number 14, the cosecant of 120. Well, let's find the sine of 120. Since you are in the second quadrant, sine is going to be positive. Mark out the 120, find out its reference angle. How far is that from the 180 x-axis? That'd be 60 degrees away. Look at your chart or look at your unit circle. The sine of 60 is root 3 over 2. So therefore, the cosecant would be the reciprocal of that, which is 2 over root 3. When you rationalize, you get 2 root 3 over 3. Next up, the tan of 270. Okay, 270 is located here. And let me kind of sketch out a unit circle as best I can. Let me try that again. That looks a little bit better. Okay, 270 is going to be located here. The tangent, okay, if we know the x and the y values there, then we know the tangent, because tangent is equal to y over x. So the point here on my unit circle is going to be 0, negative 1. So tangent is going to be y over x, but I got a problem. Negative 1 over 0 is undefined. So therefore, my tangent at 270 degrees will be undefined. The cosine of negative 150. Let's first off find our reference angle. So 150, well, let's see where that's located. That's going to be somewhere right in here. Therefore, cosine of negative 150, all students take calculus. Cosine will be negative. Tangent's the only thing positive. Our reference angle right here, we are 30 degrees away from the x-axis. The cosine of 30 degrees is going to be root 3 over 2. So therefore, the cosine of negative 150 is negative root 3 over 2. Cosine of 3 pi over 4, let's change 3 pi over 4 to degree measures. Pi over 4 is 45, so 3 45s, that's 135 degrees. Sketch it out. 135 is located somewhere over here. All students take calculus. Sine is the only thing positive, so therefore cosine is negative. Your reference angle is how far you are from the x-axis. That is a 45-degree angle. So therefore, instead of 135, let's find the cosine of 45, which is root 2 over 2. So final answer, negative root 2 over 2. Tangent. Tangent is equal to y over x. So we need a y value and an x value in our unit circle here. So the tangent of, well, first off, let's change that to degrees. Pi over 3 is 60. So this is the tangent of 120. Let's sketch that. 120 is located somewhere over here. So if this is 120, how far are you from your x-axis would be a 60-degree angle. So we don't have to worry about 120. We can worry about 60 degrees. However, we do need to know, since we're in the second quadrant, all students take calculus. Our answer here is going to be a negative because sine is positive, tangent and cosine would be negative. Now our x and our y value, we need on our unit circle, we need to find out what our y value would be here and what our x value would be here on this unit circle. Our y value would be the sine, because again, sine is y. So the sine of 60 would be root 3 over 2. Our cosine value would be 1/2. Flip and multiply, you're going to get negative root 3 is going to be your tangent value. Or you can just say, what is the tangent of 60 either way? You could have done it either way. So next one is a quadrantal angle. We're going to find the tangent of pi over 2, which is 90. The tangent of 90, let's go back up here. That's going to be located right here. The tangent is going to be, this is the point 0, 1. So tangent would be y over x, which is 1 over 0. You got to be careful because that's actually undefined. However, the cotangent would be the reciprocal of that, which is not undefined. The reciprocal of 1 over 0 would be 0 over 1, which is 0. So therefore, the cotangent 90 would be 0. To find the secant, let's find the cosine instead. Negative pi over 4 would be negative 45 degrees. Negative 45 degrees, when you sketch it, is going to be located down here in the fourth quadrant. Our reference angle here would actually be a 45-degree angle. Okay, the cosine of that angle, all students take calculus. Since you're in the fourth quadrant, cosine is positive. Now we don't have to worry about the negative 45, we worry about its reference angle, which is 45. And the cosine of 45 is root 2 over 2. This is the cosine of negative pi over 4. However, to find the secant, which is what we're looking for, we got to flip that. That's going to be a positive 2 over root 2. Rationalize by multiplying top and bottom by root 2. These will cancel and leaves you with just positive root 2. Tangent of 5 pi over 4 is actually the tangent of, let's change it to degrees, that's 5 times 45, which is 225. Let's sketch that. 90, 180, 270, so 225 is somewhere in here. It's in the third quadrant. All students take calculus, so therefore tangent is positive. Don't worry about 225, worry about its reference angle. How far is that from the x-axis would be a 45-degree angle. And the tangent of 45 is 1. So therefore the tangent of 225 is also positive 1. And finally, the cosecant of negative 5 pi over 6, we're not finding the cosecant, we're going to find the sine. We're going to find its reciprocal. And that's going to be negative 5 pi over 6, turn it to degrees. That's negative 5 times pi over 6 would be 30. 5 times 30 is 150. So we're finding the sine of negative 150 first. Let's sketch it. So negative 150 here is 0, negative 90, negative 180. So we're somewhere over here. All students take calculus. Are in the third quadrant. So therefore tangent is positive and sine would be a negative value. Find your reference angle, which is the distance from 150 to 180, which is going to be a 30-degree angle. And now simply find the sine of 30. And the sine of 30 is 1/2. That is the y value on your unit circle.